welcome to an algebra tutorial video. We are digging into the slope-intercept form of a linear equation. It's awesome, it's good stuff. So this is one of my favorite things. Slope-intercept form is simply this. It's y equals mx plus b. If you've been watching my video series, working our way through linear graphs, we've been working with slope-intercept form this whole time. But now we're ready to formally derive what this thing is and what it means. So we've been finding slopes. Slope of a line is simply m. It's our average rate of change. It's what's being repeatedly added. So if you have it in slope-intercept form, we call it that because m is the slope of our line. It's a really critical thing. It tells us what angle the line is increasing or decreasing, how much, how little, etc. So m is our slope, and we're going to have lots of fun with slope. Then there's also this value b, and b is simply the y-intercept. It's where our line crosses the y-axis. For every line, I need to know the angle. It's either increasing or decreasing. That's the slope, but I also have to have at least one point that I know that that line goes through. I need both those things to be able to define my line. So there we go. Y equals mx plus b. It tells me the relationship between x and y based off a starting value, the y-intercept, and what we're repeatedly adding, the slope. So let's take a look at an example and see how it relates to a table and graph, and we'll just take it from there. So let's do y equals 3x minus 5. All right, based on what I'm told, based on the slope-intercept form, my slope of the line has to be the coefficient or the part multiplying x. In this case, it's 3, because this value for 3 is multiplying x. So the slope of the line is 3, which means I'm adding 3 over and over and over again in my pattern. I also need the y-intercept. So if 3 is my slope, my y-intercept, the value for b, it's going to be equal to negative 5. All right, so how does that look like on a table of values? Well, let's make x. Let's make y. Let's pick some values for x, 0, 1, 2, 3, 4, and 5. And now I can use my slope and y-intercept to kind of think through these things. The y-intercept is the y value where it crosses the x-axis. Realized I forgot to put a little t. Intercept, there you go. So the y value, if the y-intercept is negative 5, that happens when x is 0. It's the only place to be on the y-axis. So my y-intercept of negative 5, I'm going to put it right there. Y-intercepts always mean x is 0. Now from there, my slope is 3. So every time I change 1 for x, guess what I'm doing over and over again? I'm going to add 3. So negative 5 plus 3 is negative 2. Negative 2 plus 3 is positive 1. 1 plus 3 is going to be 4. And we're getting that nice linear pattern of plus 3 over and over again. The next one will be 4, 7, 5, 8, 10. So there we go. We got some points. Now let's see what this looks like on the graph. My y-intercept is negative 5, so I'm going to find my y-axis right here. Go down 1, 2, 3, 4, 5. I know that point has to be on the graph based on that's what the y-intercept is. Now my slope of 3, I can think of that as my y values change by 3 every time x changes by 1. So we can write every whole number as a fraction over 1. So if I want to find other points, we go over 1 for x and up 3 to 3 for y, and I make another point. That point is also on the line. Go over 1. Every time x increases by 1, I go increase another 3. 1, 2, 3, and that point is on the line. I can follow this same linear pattern, 1, 2, 3. That's also there. Just to double check, I'm told 5, 10, so let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see that this point that we found on the table is also going to be on the line. So there we go. We got a nice linear pattern. Let's fill out that 0.47. Because it's a line, because I can put any x values in, I actually need to draw the full line and connect all the points up. So right about there is a pretty good line. And that line represents all the points that are solutions, all of them. It's like if I put 100 million dots all on that line, that all those dots would represent x and y values that make that equation true. So there you go, slope-intercept form. We like it, it's convenient, it's really easy to put things in for x and find y values. It's really easy to graph because we know the slope and the y-intercept just by looking at it. And it's a very handy form to write linear equations in.